Hello everyone, today we are going to study solutions and qualitative properties. What is a solution? People simply answer that solution is a mixture of two or more substances. But mind it, the solution is a homogeneous mixture of two or more substances. Homogeneous mixture means that composition of a substance is uniform throughout the mixture. For example, in salt solution, the salt is evenly distributed in the solution. A solution consists of two components, solute and solvent. The component which is present in less amount is known as solute, whereas the component which is present in large amount is known as solvent. For example, in salt solution, the salt is present in less amount, therefore it is solute. And water is present in large amount, therefore it is solvent. And salt plus water makes salt solution. That is, solute plus solvent makes a solution. Now, we often have heard about the term dilute and concentrated. So here, the concentration means the amount of solute present per amount of the solvent. And the dilute solution means that solution having a little dissolved solute as compared to the carrying capacity of the solvent, whereas the concentrated solution have an amount of solute that approaches or is at the carrying capacity of the solvent. That is, the dilute solution have relatively less amount of solute and the concentrated solution have more amount of solute in the solution. Now, the methods of expressing the concentration of solution. We have different methods for expressing the concentration of solution. These are percentage concentration, molarity, molality, mole fraction, parts per million, and normality. So, the first method is percent concentration. It refers to the amount of solute per 100 parts of solution. It is also called as parts per 100 and it can be expressed in the following ways. First, the weight percentage. Mass of solute divided by mass of solution into 100. Percentage volume. It is the volume of solute divided by volume of solution into 100. Percentage weight by volume. The mass of solute divided by volume of solution into 100. Percent volume by weight. Volume of solute divided by mass of solution into 100. The next method is molarity. The molarity of a given solution is defined as the total number of moles of solute per liter of solution. Its unit is moles per liter or molar, and it is dependent on temperature, as we can see here that the molarity is the number of moles of solute divided by volume of solution in liters, and volume of solution it changes with temperature. The next method is molality, that is small m, and molality is defined as total moles of solute present in 1 kilogram of solvent, and its formula is moles of solute divided by mass of solvent in kg. Its unit is moles per kg or molal, and it is not dependent on temperature as mass is independent of the temperature. Other method is mole fraction. Mole fraction is equal to the moles of one component divided by the total number of moles present in the solution or mixture. Its formula is number of moles of a component divided by total number of moles of solution. And mole fraction of solute plus mole fraction of solvent is equal to 1. That is, the sum of the mole fraction of solute and mole fraction of solvent is always equal to 1. So, if we have to calculate the mole fraction of solute, then it is moles of solute divided by moles of solution. And moles of solvent is moles of solvent divided by moles of solution, and their sum is equal to 1. So, suppose a solution is composed of two components A and B, then mole fraction of A is number of moles of A divided by the number of moles of A plus number of moles of B, and mole fraction of B is equal to number of moles of B divided by number of moles of A plus number of moles of B. The other method is normality. The strength of the solution is measured in terms of gram per equivalent per liter is called as normality. It is denoted by capital M, and the solution having 1 gram equivalent of dissolved salt in 1 liter of its solution is called a normal solution. The normality formula is number of gram equivalent of solute divided by volume of solution in liter, and the number of gram equivalent of solute can be calculated by the gram equivalent mass, that is mass of solute divided by equivalent mass, and equivalent mass is molecular mass divided by number of hydrogen ion and hydroxide ion, which is acidity or basicity. For example, we have to calculate an equivalent mass of an acid, then the equivalent mass of acid is equal to molecular mass of acid divided by number of replaceable H plus, that is the basicity of the acid. So here for HCl it is 1 because it has one H plus ion, so its basicity is 1, and the equivalent mass of HCl is 36.5. Equivalent mass of H2SO4, it is the molecular mass of H2SO4 divided by 2 because it has 2 replaceable H plus ion, that is 49. The last method is parts per million or ppm, and it is defined as the number of parts of solute per million parts of solution. The parts per million or ppm is equal to mass of solute upon mass of solution into 10 to the power 6, and this method is used where we have the traces of solute present in the solvent. Thank you.